everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In last few classes, we completed our discussion on PN junction diodes. Now from today, we will discuss BJT or bipolar junction transistors. Before we go deep into the topic, let us discuss the term transistor first. So what a term transistor means? Transistor simply consists of two words. First one is transfer and second one is resistance. So, transfer of resistance is something which we consider as transistor. Now here let us discuss how transfer of resistance is happening. This is emitter, base and collector. These are the three terminals of transistor. Now emitter base junction have few resistivity and base collector junction have few kind of resistivity. And emitter base junction is considered as input and collector base junction is considered as output. So here we can see that input resistance and output resistance are differ in nature. What is happening here? Simply we can say that we are transferring few input to the output. Similarly, the resistance of input is transferring to the output. The transfer of resistance is there. Whatever in the input node and whatever is the output node is linked toward the transistor with emitter base and collector junction. So emitter base has few resistivity and few resistance property. Collector base has few resistance or resistivity or resistive property. So here the transfer of resistance is there. From input to output we are doing nothing but just transferring the resistance, because in this what is happening? Transistor is a current control device. Now what a term current control means? Simply transistor is our current control. Current control means that its switching or its on off operation depends on the current only. So here I and R both are the major components of a transistor. I, which is current control, the switching or the on off operation depends on the current only. So this is the current control device. Transistor is a current control device. And resistance, because of at input and output the resistance is differing, and the transfer of resistance as a meaning we are considering as a transistor. Okay, now we will discuss it in more detail. Now this is the classification of transistors. How many type of transistors are found? So BJT, we already know, bipolar junction transistor. FET is our field effect transistors. BJT further classified as PNP and NPN. Now PNP, holes are majority, NPN, electrons are majority. Holes and electrons are nothing but the charge carriers which we use to make intrinsic semiconductor extrinsic, and holes are majorly found in trivalent impurities, which is nothing but group third element of periodic table, and electrons majorly found in pentavalent impurity, which is nothing but group 5 element of periodic table. The detailed discussion on how intrinsic or extrinsic type of semiconductor are behaving, we already discussed in last classes. You can check from the playlist. Now this is FET, field effect transistors. JFET, junction field effect transistor, and MOSFET, metal oxide semiconductor field effect transistor. So this is the basic criteria which we will study inside the transistor topic. BJT we will study and FET also we will study in later classes. Now we will discuss how a transistor is made up of. Transistor is nothing but a PN junction connected back to back. Okay, two PN junction. Let's suppose this is P and this is N. Similarly, this is P and this is N. And this N and N is sandwiched and making a particular layer. So this is our PNP transistor. Similarly, we can construct NPN transistor also. So in a simple manner, PN junction diodes is connected back to back in this manner. Okay, so this is the configuration of how a PN junction diode is behaving. Back to back connection of PN junctions. Transistor is nothing but PN junction, simply because P and N sandwiched between P and N. This is the basic structure of how a transistor is making. Now we will discuss it in little detail. Let's say this is emitter, this is base and this is collector. So what is happening here? Emitter is very heavily doped, base is lightly doped, and collector is our moderate doped. Now what is the meaning of that collector moderately, emitter heavily and base is lightly doped? The work of this emitter, the work of this emitter is to supply majority charge carrier to collector. This is the supplier. So it is heavily doped. Why so? Because it is supplying more charges towards the collector. So it should be heavily doped so that the flow of charges will increase. So it is the heavily doped. Similarly, collector is the receiver or it's a sink. So it is moderately doped. If it will be heavily doped, what happen? The charge carrier which is coming from emitter to collector will try to combine with each other, creating loops and meshes. So the flow of the flow of charges in a particular manner will disturb. So at collector we will do a moderate doping so that the charges which are coming from emitter will directly enter to the collector and the flow will be maintained. Okay, so main function of collector is to collect majority charge carrier. Okay, now here we can see that collector based junction is always reverse bias. Clear? Understand this. Collector based junction is always reverse bias and emitter based junction is always forward bias. Why so? Emitter based junction is forward bias because uh, it is simply a PN junction, and in PN junction we know that forward bias means high current will generate. If high current is generating, it means it can produce the high current. It can flow towards the collector. A high current or majority charge carrier will flow towards the collector. Similarly here, reverse bias in PN junction simply means the blocking bias. Here we can't consider it blocking because few collector current we also need. Here the main function of this collector is to hold those charges which are coming from the emitter, so that the output current, which is nothing but IC collector current, will be increased in a particular manner. So base collector junction is always reverse bias and emitter base junction is always forward bias. Okay, now this middle section is our base, which is lightly doped, very lightly doped. Why so? Because to reduce the recombination within the base. Okay, if recombination process occur inside the base, what will happen? Charge carrier will recombine each other, and recombination doesn't create any flow of charge. Recombination simply means holes captured by electrons. So hole and electron recombine and they generate few kind of energy, but they do not take part in conduction. For conduction we need free moving electrons or holes. So recombination is a process in which hole capture the electron or similarly electron capture the hole. So energy will energy, heat, and whatever the energy dissipation is there, but the existence of these charge carrier will be stopped. So recombination process, to reduce the recombination process, this is lightly doped and is very thin. So this is lightly doped and lightly doped. So and the layer is thin. The layer is thin so that the charge carriers will easily move from emitter to base. Okay. So this is the basic construction diagram of what emitter, base, and collector are, and what the a little basic understanding of these. Now this is the structure of our NPN and PNP transistors, emitter, base, collector, PNP, and NPN. P layer is in between in NPN and N layer is between PNP, and this is the symbol for PNP and this is the symbol for NPN. Here we can see three type of current are there: emitter current IE, collector current IC, and base current IB. Similarly, here also IC, IB, and IE. Now, one thing one has to note it that the arrowhead is always connected with the emitter. So this arrowhead is inside the circle is always connected with the emitter and it show the flow of the current inside the BJT. So the flow of current is towards the base in case of PNP and from base to emitter in case of NPN. So this arrowhead which is inside the circle here is just showing the flow of the majority charge carrier or flow of the current, which is from IE to IB, emitter to base, and in case of NPN it is IB to IE, from IB to IE this is base to emitter. So this is the basic notation diagram or symbol of NPN and PNP transistors. Now this is the basic physical diagram of transistor. This is the 3 leg terminal transistor, and you can count the 1 2 3 from here: emitter, base, and collector. 1 2 3. This is the number BC547, which is very common in our electronics lab. So this is the basic very basic BJT transistors. Now how you can read those numbers? The IC number is mentioned over here, so you write from the leftmost, you consider emitter, and in between base, and in between and at last or the rightmost corner it is collector. So this is the emitter, base, collector configuration in a particular transistor. So in today we just discuss a very basic or a few basic understanding of how a transistor is and how its emitter base and collector junctions are. Now in next class we will discuss the band gap and the biasing of the transistor, that how we will do bias and how the current are traveling inside the transistors. So for today this is much. I will see you in next class. Thank you so much.